Let's dive into machine learning using C#.NET. And if we need to, we'll use Python as well. This is going to be some kind of speed run through the machine learning basics, covering some statistical models and even neural networks. I'm going to focus on how to do it with C#.NET. So implementation-wise, I'm not going to go too deep into the theory. If you want to go really into depth, there's likely a ton of very in-depth courses out there using Python, R, or something else. And I'd recommend you take one of those if after this introduction into the basics, you decide to pursue a career in machine learning, deep learning, or AI. Some of you may have been lucky enough to get this introduction to the machine learning basics in your education, like in school, college, something like that. If that's the case, what I'm about to tell you may not be anything new. In the year 2020, I went back to my college to follow an extra course in artificial intelligence at home, from which I've got my basic understanding of machine learning and implementing machine learning. And of course, after that, I applied machine learning as well. So I'll try to add that experience into the videos. What I'm saying is a little bit outdated. Do go to the comment section and speak your mind. I'm definitely willing to for you to correct me or prove me wrong if I'm stating things like what machine learning is not yet. What I think is not yet an unstoppable conscious entity, infinitely self-learning. Because self-learning systems, that's how we sometimes talk about machine learning, but it's not like the movie, forgot what the movie name is, Scarlett Johansson is basically an AI and she connects to the internet and she becomes one and takes over and things like that. That doesn't seem to me to be the case just yet because machine learning and AI is very dependent on quality data, and quality data often still comes from humans, produced by humans, and maybe even limited by humans. That's what I think, at least. Feel free to prove me wrong. So I see AI as a great asset, but not yet as an autonomous replacement of people, the human mind. Okay, so what you don't need machine learning for is problems that have a fixed formula. For example, the Pythagoras theorem, or that's a fixed formula. Another example, the body mass index, that's a fixed formula. We don't need AI or machine learning for that, because so then what we do use machine learning for is to solve a problem of which, well, a problem that doesn't have a fixed formula, or at least we don't know the fixed formula for. So with machine learning, we aim to find the best fitting formula approximation to solve that problem. It's never going to be 100%, but we're going to try to get as close as possible to 100%. For a machine learning model to reach 100% accuracy, that either means, it's mostly an error, that either means, maybe there is a fixed formula and you don't need machine learning, or it means the model is overfit. We'll talk more about that later. We want a machine learning model that can perform in the real world, so can make proper predictions on new data, on unseen data. An overfit model that would perform 100% on the data we showed it, possibly has learned that data and only that data, and may not perform too well on new data. We'll talk more about overfitting and underfitting later on in the course, because we're getting ahead of ourselves. So what is machine learning? It is training a model to make predictions, classify data, or make decisions, take actions based on input data. The self-learning aspect here is that the model improves itself, should improve itself, the more data it sees and the more it can learn from the data, train on the data. That historic data is data that we have. We know the input and the output of, which means for example, the typical example is predicting house prices very simplistically. Let's say a one-bedroom house costs about $225,000 or euros, whatever you want, 280 maybe. And another house with 3 bedrooms may cost around 600,000. Then maybe you want to make a prediction on a house with 2 bedrooms or with 6 bedrooms. Yeah, so we kind of need to learn an approximate formula for predicting house prices based on the number of bedrooms, which is a very simplistic. There's way more factors that weigh into that house price, but okay. So that would be predicting a continuous value, they call it. Like it could be 220,000, 600,000, this or that or that. Then you have classified data, which is, we'll see in one of the next videos, just mostly like, is it an apple or not? Or you could say, is it an apple or is it an orange? That falls within classified data and more. But let's continue. So how does a machine learning model improve itself? That's usually done. So we're feeding it training data of which we know the inputs and the outputs, and we'll feed it to the model. The model will, usually we call that epochs or batches, will go through that data and try to make a prediction based on the input. And then it's going to compare how wrong its prediction was compared to the actual output, which is included in the training data. So, and then the goal is to minimize the error rate, so to be as close as possible to the actual output, so that the predicted output is as close as possible as the actual output. And it uses a loss function. If you want to dive into the formula for that, feel free to. So that's a very simplistic illustration. We have an axis, y-axis, x-axis. We don't know the value for x. So, well, I kind of switch them. Normally you'll see x as the input data and y as the output data. So I'm going to switch it. And we have a number of data points. So that would be our historic data. And then it's going to try to fit. So try to predict the best formula. Let's say it goes here. It may have small error rate on some data points, but not on the others. If it goes too low here, the same thing. And then maybe in the middle, maybe there in the middle line has the lowest error rate, then that's going to translate in your accuracy. So the opposite of that. Okay. That's a very simplistic. We'll keep everything very simple in this basics course. So machine learning has been around for a while, but it's accelerated over the last years because of, well, the new technology that we have, the GPUs, the stronger computers, and those, and also the development of neural networks. It's also more accessible now to the everyday person. So, okay, artificial intelligence is more like the overarching domain. Any technique enables computers to mimic human intelligence using logic, if-then rules, decision trees, and machine learning, including deep learning, but also maybe other techniques to do OCR or other kinds of, or edge detection or things like that, definitely. And then machine learning is a subset of AI that includes statistical techniques, so mostly statistical models, and to learn from that, self-improve, tasks based on experience, which is the historic data, but it also includes deep learning. And deep learning is then more specifically about the neural networks. So we'll definitely cover neural networks, but we'll start with the statistical models. Okay, some common benefits: improved efficiency, enhanced decision making, increased accuracy. Well, it's being used in a set of industries now, and the common example is pattern detection in many industries, but then, for example, for cancer cell detection on microscopic imagery, things like that, it seems to work quite well, and maybe sometimes better than humans. So real world applications, maybe you know some, feel free to comment them. Let's see. So locating structures and images, that's the pattern detection, or structures and documents and extract its contents. That could be, well, OCR, optical character recognition, but could also be detecting that it's an invoice, or certain structures like tables or things like that, prices and so on. So automated document processing, spam and fraud detection, could be email classification. If it contains a promotion or maybe something suspicious, then we could start classify them as spam, or maybe, and fraud is them more in the banking industry. Anomaly detection is in there, I think. Unusual stuff, detect unusual behavior. So email classification, you could forward the certain emails to the correct department, so that could improve your business in that way. Forecasting monthly expenditures, like you see in your maybe see in your cloud dashboard, like from Azure or Google or Amazon, you may see your monthly estimated cost. Pattern recognition in the stock market, detecting like a head and shoulders pattern or things like that. And entity recognition and chatbots, I put that together. Entity recognition is more like, okay, this part of the sentence contains a date format or something else, and in that way, basically recognize the entity of a certain word. And chatbots use that to train on, but also to extract useful info and things like that. And search engines using vectors and vector databases are also a thing these days. It's basically a more efficient way to compare or to find similarities in data instead of doing literal text comparisons or character comparisons. You kind of embed words or characters, and then you find the closest, the most similar embeddings, or the nearest embeddings or vectors. And yeah, that's more a better way to search to get, for example, all kinds of related products or things like that on your search engines, not just a literal contain function. Okay, a few fields, predictive analytics. To make predictions and forecasts on historical data. So that's what we'll start with, using the statistical models, regression analysis, predicting house prices, like based on features like location and size. Note features, we'll see that word more in the course. Feature is going to be the X value, the input value, and the house price would then be the label, what we call, or the output value. Time series forecasting, which is more useful in predicting stock prices, for example. It can look a bit back in time and a bit ahead of time or something, and take all of that in. So what comes before and what comes after your historic data point. It will also learn that to make better holistic predictions. If I'm not mistaken, that's also what's inside of your smartphone keyboards. If you're typing sentences, sometimes it's gonna learn what you usually put before a certain word and after certain word. Can help learn more about the context and so on. Recommendation systems suggesting products or services based on user behavior. If the user has often viewed certain product, you could suggest similar products. We'll see see more about that. Computer vision, it's like OCR, image classification, identifying objects and photos, object detection, locating specific objects within an image, facial recognition, which is blunt but an object in an image. Whoops. Natural language processing, is more about well, text, speech, and so on. Sentiment analysis is this review, for example, a positive one or a negative one. If there's many bad words in there, we can assume it's a bad review. Okay, text classification, categorizing articles or emails into topics or genres. Machine translation, translating text from one language to another. Okay, then types of machine learning. That's why I was talking, well, the recommendation engine is an example of unsupervised. So we've got supervised learning, unsupervised learning, and reinforcement learning, and there may be more. Supervised learning is trained on labeled data, so we have the inputs and the outputs, so the historic data. Both the inputs and the outputs are already known, so that house price prediction, we know the inputs, we know the outputs. So inputs is amount of rooms, output is the house price. Image classification could be similar. So let's say, is this a cat or a dog? Then we would need a data set of images, historic data of dogs and cats labeled correctly. And supervised learning is more like we do have the input data, but we don't have the output data, which is a bit strange. But it's more like grouping things together, finding patterns in, well, a bunch of data that looks unstructured. So that could be that recommendation engine, that recommendation system. Then we can kind of find the groups of users and give them a more tailored user experience or more tailored recommendations, similar customers. Okay, reinforcement learning is a bit like the AlphaGo, the chess learns how to play chess and things like that. Basically, an algorithm learns by interacting with an environment and receiving feedback in the form of reward or punishment. It's a bit like almost like training a dog as well. Supervised learning trains on historic data. The inputs and outputs are known. Okay. We've seen that. Applications, image recognition, self-driving cars, which, well, likely uses more than just that. There may be a bit of reinforcement learning in there as well, but this specific example, self-driving cars, used to recognize pedestrians and road signs. So to learn road signs, we need imagery of road signs labeled correctly. Unsupervised learning, find patterns in unlabeled data. So we have the inputs, not the outputs. And we don't have specific output in mind, let's say. Well, not defined outputs anyway. We're not gonna be able to say, okay, this group of customers likes apples and this likes pears. I mean, we won't know that in advance. Let's just say it like that. But the model may turn out to illustrate that. Reinforcement learning, AlphaGo, chess components, maybe some kind of other. There's many more applications to that. Definitely do comment if you know some. So as you see, we're going through it rather quickly, not too into depth, but just enough to learn the basics. Next episode will be about regression, so linear regression, which some of you may have seen in school, mathematics or not. But here we're going to train that algorithm to make predictions. For example, the house price based on amount of rooms. And linear regression is going to look more like this, simplistic predictions. And then after that, we may see logistic regression, which is more like classification, is drawing a line between two or more types of data. So apples, oranges, pears, maybe, things like that. Okay, this notebooks will always work in those notebooks. If you don't know how to get those into VS Code, I'm just using Visual Studio Code, but it's basically then you can go watch my video on Jupyter Notebook for C Sharp, VS Code.NET. At the time of recording, I had not installed all of the necessary components to do proper machine learning inside of these notebooks. I also explained why we would use those notebooks. This time I do have everything installed, and I'll show you before you need it. So I'll see you in the next episode. Make sure to leave a like and subscribe if you want to follow along. I will put everything you've seen now, which is just some text, in the notebook and Markdown on my Patreon, and it's just going to be a freebie. Once I start really coding and things like that, you can become a member to get access to all of that. But it's going to be rather simple code, and I think you'll be able to just maybe type it over from the YouTube video. But if you want to become a member, that definitely helps me out, and maybe make sure that I can spend a bit more time on these types of videos. Speaking of, if you have need someone to solve your business problems using AI, you can hire me via my website, giscode.com/hire me. Just hit the hire me button,